How different is today's Indian Air Force from the one you joined?
When I joined Air Force, the Air Force was made up mostly of MiG-21s. Today, there is no MiG-21 in Indian Air Force. It retired in 2025. Today's systems are all integrated, networked, they are software heavy.
For the decades, fighter aircraft have been categorized into generations.
Generational categorization of fighter aircraft started around in 1940s when the first jet engine powered fighter aircraft appeared. But when we came to 4.5 plus, now what did the computing capability has increased manifold. A 4.5 generation platform which is within a network will outperform a 5th generation platform which is not on the network. What is today's aircraft? It is the backbone is a mission computer. This software becomes the heart. So software is like an enabler. So it's both hardware and software which are extremely important to complement each other.
Less number of aircraft squadrons left with Indian Air Force.
We cannot jump from 4th generation to 6th generation till we don't go through the learning process of 5th generation. So how do we shorten this process?
There have been questions on the 12 aircrafts per year and the engine has been delayed.
The funding for research and development must increase. The entire infrastructure for research and development, whether it is facilities, whether it is certification, whether it is testing, whether it is simulation. You know, Sindoor is more than 1 year old. What have we brought new after Sindoor as a capability for the Indian Air Force?
Namaste and welcome to the very first episode of the Life of Soldiers podcast. It's our privilege to begin this journey with one of our esteemed guests, who is Air Marshal Ravi Kapoor, sir. Sir, thank you for coming to this podcast and thank you for blessing us with your guidance and the inputs every month.
Thank you, Vinay. Thank you for having me over. And I think the opening episode will set the tone, hopefully, for many more episodes for the Life of Soldiers podcast. And it will enrich a lot of people in this nation.
Thank you, sir. Just to give a small introduction about Air Marshal Ravi Kapoor, served the nation with distinction for more than 4 decades, culminating in his appointment as Air Officer Commanding-in-Chief of Central Air Command. As a fighter pilot and strategic leader, he has contributed significantly to capability development, operational planning, and the modernization of the Indian Air Force. Sir, before we start with a discussion, I would like to start with a personal question. First inspired you to become a fighter pilot?
Oh, my father was a meteorological officer in India Meteorological Department, and so he was always posted at an airport. So I grew up seeing not many fighter aircraft, but I grew up seeing many commercial aircraft. So as I grew up, my love for flying continued to increase, and later when I was in college, I joined NCC, and in Air Wing I started flying, and that is when it became clear that yes, this is a passion for me.
Sir, looking back your career, what remains your proudest moment in the uniform?
Oh, there have been many proud moments in uniform. So I can't single out one proud moment because the best time is when the team you are leading performs well, and that has happened many times on many occasions. And I think whether it was air to ground firing, whether it was operational flying, whether it was planning for missions and doing things like that gave me the maximum satisfaction. And the other things were whenever you were called upon for certain specific things, whether it was Eastern Ladakh or Balakot strike or anything after that, it gave you the satisfaction that yes, you are contributing to the cause and the mission effectiveness.
Which was the most exciting part during that point of the time, sir?
I think very exciting was handling Assistant Chief of Air Staff Intelligence to coordinate with many other agencies and others, and to ensure that what we produced was of value, and do a lot of other projects which added to our capability.
Sir, how different is today's Indian Air Force from the one you joined years back?
Oh, it is hugely different. When I joined Air Force for training in 1985, and then when I got commissioned in 86, the Air Force was made up mostly of MiG-21s. Today, there is no MiG-21 in Indian Air Force. It retired in 2025, as you know. So, the basic huge difference in terms of technology, huge difference in terms of how we approach issues, and huge difference in terms of how we train. It's vastly different. It's the challenges that we faced. Things were very simple. MiG-21 was a very simple aircraft, though it required very good pilot skills. But as a machine, it was simple to handle. It was simple to do your missions. It did not entail long hours of briefings and debriefings. Today's systems are all integrated, networked, they are software heavy. They have many systems which are performing diverse functions, from radar to radar warning receiver to electronic warfare to mission planning. Everything is happening on a computer. So, and then earlier MiG-21 would fly for a very short duration. Today the aircraft fly for say 6, 8 hours, 10 hours also, with the air-to-air refueling. And so the demands on pilots are different. The missions are very, very complex. You are flying many missions in one go. In a MiG-21, you only did either air combat or you did air-to-ground weapon delivery. Today's mission, you take off, you do air combat, then you do electronic warfare, then you do air-to-ground weapon delivery, then again you do another mission. You could even combine it with a maritime mission, and then after 8, 10 hours come back to your base or land somewhere else and then come to your base. So it is very, very complex. And you are now flying across a much larger area. You are flying with many, many more aircraft than we did. Earlier, we used to be constrained to our squadron. Within the squadron, we would train. Today, you are training with other squadrons, other types of aircraft, other types of weapon systems. Everything is coming into an ecosystem. What the Indian Air Force has created today is integrated training area, where everybody comes and trains together in as realistic conditions as possible. So the Air Force that we saw when we joined Air Force to what Air Force is today is highly professional. Not that we were not professional, we were professional for the machines and the tasks that were given or the objectives that were defined at that time. But today's air combat, air campaign and air planning, mission planning and all are much more complex, much difficult. The pure, flying skill that was required in our time has given way to a much more higher degree of situational awareness requirement, higher degree of systems handling, higher requirements of working with a much larger number of aircraft in a very, very constrained space. And so your how you handle systems, how you manage systems, how you understand them, and how you take decisions is become a much different kind of Air Force today.
Coming on to the same point, for the decades, fighter aircraft have been categorized into generations, 4th, 5th, and 4.5, and a 6th generation as well. So while this framework has helped explain technological evolution, and it also raises an important question, are fighter generations still the right way to measure combat capability?
You see, this generational categorization of fighter aircraft started around in 1940s when the first jet engine powered fighter aircraft appeared. And from then on, almost a decade, each decade, we have had one generation. So 40s, 50s, 60s, 70s. From 70s onwards, when the 4th generation came, somewhere middle of 70s to 80s, From there onwards, there has been incremental increase in their capability. Earlier, it was all what made up that platform, what made up that fighter. Whether it was only guns, whether it was missiles, whether it was radar, whether it became radar warning receiver, then it became beyond visual range air-to-air missiles, long-range precision strike weapons, and things like that. But as the technology progressed, electronic warfare came in. Then, you had a radar, then you had a infrared search and track, which is a passive sensor. So the number of sensors on an aircraft continued to increase on the same platform, on the fourth generation platform that we call. So from there it became 4.5 generation, where you had multiple sensors. That means you had a radar, you had a radar warning receiver, and you have electronic warfare capability. And then came the 4.5 plus generation, where the IRST came, that is infrared search and track. That means you're passively looking at another aircraft, because every aircraft is emitting heat through its engines or friction on its metal structure. You are trying to capture that heat signature and then convert it into range. So that is a passive. Without radar, when you transmit something, the other person will hear it or monitor it. Now what you are doing is you are sensing your own, the enemy's radiation. And so when these came, and now 4.5 plus came, in which you got certain amount of low observability in terms of certain aspects of an aircraft, where it delayed detection by a radar. It delayed detection by optical, or that means your visual detection. Certain amount of thrust vectoring came. And then sensor fusion came. That means earlier in a 4th and 4.5 generation aircraft, one would see a radar picture, radar warning receiver picture, and another whatever else electronic warfare picture. 3 pictures separately on his 3 multifunction displays. And then he would try to combine analyze all of them, then make a picture out of this 3 as a single picture, and then react to a situation or act accordingly, which demanded a lot of time and skill from the pilot, and then a lot of cognitive ability. But when we came to 4.5 plus, now what did the computing capability has increased manifold. Because you have a very high level of computing capability, you could now, what you could do is you can leave all these functions to a computer, who would now integrate all these inputs and then present a pilot with a single picture. That means he did not have to look at 3-4 displays. What we added later on a 4.5 plus is we tried to make it as close to a stealth platform. That means radar absorbent material, radar absorbent paint, in terms of some kind of supercruise. Like you see Rafale and Typhoon and these aircraft. These aircraft can supercruise. That means to fly at a little supersonic range, you do not have to engage reheat or afterburner. Now, when you engage afterburner, your heat signature increases. So when your heat signature increases, you can be picked up by your adversary, at a larger range. And so to reduce that and get the advantage of speed, you go into a supercruise. That means you have a much more efficient engine, more powerful engine, which will give you a higher speed, above speed of sound. So it could be 1.1, 1.2, 1.3. The supercruise word was actually coined by the Americans. So when they built F-22, the Raptor, actually the second stealth aircraft, the first was F-117 Nighthawk. So then they built F-22 Raptor, and F-22 Raptor, they said supercruise means you should be able to fly sustained at 1.5 Mach without using afterburners. And so that has become the benchmark for supercruise. But there are aircraft like Rafale, the Typhoon, the Su-35, even Su-57, which is a stealth aircraft, but all these aircraft can do supercruise. But you'll be surprised that F-35, which is a fifth generation fighter, cannot supercruise.
So coming on that point, has modern air combat shifted from platform-centric warfare to network-centric warfare, considering all the computational capabilities that has been integrated into the aircraft and airframes itself?
See, today we have gone from a single domain operation, which was a very inefficient way of war fighting, to a multi-domain operation. Multi-domain means we know there are 5 domains. India has coined the 6th domain also. So the 5 domains are land, air, maritime, space, and cyber. So these are the basic 5 domains. And the 6th domain that our multi-domain doctrine, joint doctrine, speaks about is the cognitive domain or the informational domain. So with the kind of technological evolution, fighting just in one domain is very inefficient, very expensive, and you are always behind your adversary in the OODA loop, unless you're just focusing on the single domain versus single domain. But since the effects we are talking about now, no more that what is the damage we are creating. It is the effects that you create. So it is like, striking the leadership will create a much bigger effect than, bombing one small factory. So that is the kind, when we say effect-based operation, that is the effect. So how does it affect war fighting by the enemy? And now when we come to the multi-domain operations, you are basically looking at decision superiority. That means you are ahead of your adversary. You want to be ahead of your adversary in terms of analyzing how is the situation developing on the battlefield in all domains. And that means you have to have visibility in all domains simultaneously. How can you have visibility in all domains simultaneously if you are not networked? So if you are fighting force on force, it is attritional warfare. You do not want to fight force on force. You want to create the effect in the domain that is going to hurt your adversary the most.
Okay.
So you are based on a network. That means the information is being collected in every domain. And now the most effective way of responding or being ahead or creating an effect is there. And so platforms can only deliver a certain amount of effect. But when you do network, the effect that it creates multiplies many, many, many times. And so that is how even the generational fighters, if you see, as we come to a 5th generation fighter, it is kind of a command node. It is flying command node. That means it is taking inputs of everything that is happening in the ecosystem or in the battlefield, whether it is on the ground, on sea, in air, in space. It is constantly communicating with everybody else. So the situational awareness increases many, many more times. And if it was a single fighter, if it was a platform, then it would have had to do all these functions by itself. If a platform has to do all these functions by itself, it will be highly restricted because it depends on the capability of that platform. But now when that platform becomes part of the network, its ability to create more effects, more destruction, is much more. And so, we are going from platform-centric to network-centric. And that stealth platform that I was talking about, when you say sensor fusion, you are combining all sensors on a platform. And now when we take it further into kind of discussion, let us say today we want to discuss and say that whether a 5th generation stealth platform or a 4.5 generation, 4.5 plus generation platform, which is networked, and a 5th generation platform which is not in the network, which one would perform better? A 4.5 generation platform, which is within a network, will outperform a 5th generation platform, which is not on the network. And so the network is what is providing the information and the situational awareness which the platform and its weapon can exploit.
So a collective group of data from might be the AVAX or the communications or the ISR or even the satellite links. So these things are playing a huger role than the separate fighter platform itself.
Absolutely. So see, when we talk about ecosystem, ecosystem in the air, on the ground, the sea, space and cyber. Now that is the full ecosystem that we are talking about now. And when we have that ecosystem, AVAX is contributing to it, ground radars are contributing to it. The surface-to-air missile radars of whether it is the surface forces or the maritime forces, radars on the ship are contributing to it. The satellites are contributing to it. All kinds of other sensors which are there are also contributing to this whole ecosystem.
Are we entering an era where software upgrades determine the combat capability more than the airframe design itself?
I would not say only the software capabilities. The software adds to the platform capability. If you see, F-35 is already gone through 3 or 4 levels of upgrades in this very little time. And that is, and most of the systems like this will continue to go through upgrades.
Sure.
So the software is primarily, because see, what is today's aircraft? It is the backbone is a mission computer. The mission computer is computing or is accessing all the data which is coming, is analyzing everything, and then even using artificial intelligence with the data that is already residing, and then using that to give a very, very easy, comprehensible picture to a pilot. Now, when we look at the generation of aircraft or the platform in the 5th generation provides you low observability. Now, when you combine a very, very high end of computing power with this, with excellent onboard systems, a platform comprises of what? A platform comprises of a radar warning receiver, its engine to perform, its electronic warfare suite, its weapons, and finally the pilot. Now, pilot, if it is same, we just look at the platform. So now if I enhance the capability of each of these systems, the platform becomes more potent. Okay. Now, how do I reap the benefits of this better, each of these better systems? That means a better radar, a better RWR, a better electronic warfare suite, a better IRST, everything is better. How do I enhance the value of this better?
Yeah.
By much higher computational power, which is software. When I use this better software, I can, because now it is producing much larger data, and now when it connects with a larger number of contributors, it is going to have even more data to process. Now when it does this software becomes the heart. So software is like an enabler. So it's both hardware and software which are extremely important to complement each other. If you don't have a good enough hardware, a good mission computer, that's why we constantly upgrade the mission computer. As the data richness improves, as we have more and more data, and it has to interact with more and more systems, we will have to upgrade the system.
Sir, how has been the software technological support that is provided from the Indian ecosystem to the Indian Air Force?
I think it is. I think software-wise, we are quite good. I think LCA, the mission computer we have made, and it is performing very, very well. So there are certain areas in which I think we are doing well. And you know, Vinay, that most of the brains in Silicon Valley are Indians, and so there are I think in terms of the software upgrades and things like that. I think we have enough and more people who are doing a great job. The biggest issue, in modern aircraft is integration. How you integrate each of these systems to create that final picture. And because, everything has to come and talk to the mission computer. It has to be very, very simple, easy. It's a very complex process, but it has to be made easy. To ensure that the right message goes to the right thing. So if the weapon has to be there, then the weapon, it must recognize that this is the weapon.
Yeah.
So there are all these protocols are very, very complex to integrate. And that is the big challenge. So far as we have everything Indian, it becomes very easy.
Correct.
Because then you are developing the protocols, you are developing the software. But when you are like in LCA Mark 1A that we have today, the mission computer is Indian, the engine is American, the radar and RWR are Israeli. RWR is, I think, Indian. The jammer is ELTA. And so now when you have to integrate all these components from diverse, origin, it becomes a very, very complex process. And that is where the problem arises.
Sir, we understand that there is a complexities of the softwares because the language might be of a different tech for the different systems itself. And doing the system engineering from the background of the different nations, of the different languages, tech stacks used will be a huge issue. And is there any roadmap or any where there is a same platform where all these things could be simplified in a way in the coming years?
CV, you would have heard this word strategic autonomy, technological sovereignty. All these words have come after we coined this word Make in India and then Atmanirbharta. So it is development of software, like development of engine, is not only a complex task, but no nation wants to give it away. Because of the technological sovereignty, they want to exercise over their own thing. And finally, that is the heart of the system. The entire system works on software. So they will not share the source codes with you. They will not share the basic protocols also with you. And so it is very important that we start doing these things on our own. So it is like a data link. A data link has a waveform. So that waveform, if it is not a common waveform for all systems that are produced in India, it will not talk to each other. So an Indian waveform which is specific for the Indian military is important. Similarly, the radios or any encryption that we are doing, it has certain protocols. Again, it is driven software. So then those have to be common. So if we are going to develop things within the nation, all these things, that means the electronic warfare equipment, the radar warning receiver, the radar, the IRST, the mission computer, all of these things, the weapons. Finally, weapons also have to talk. The command has to come to the weapon to go or not go. So all that is through this computer. So while we have done the mission computer, but the mission computer has to talk to all of these things. So till we don't achieve complete Atmanirbharta, so-called Atmanirbharta on these, we will be dependent on the foreign vendor. Till we import, we will be dependent. Even if we are going to buy Rafale, what Rafales we have, if we have to integrate any of our weapons, or we can't do any modifications on that. We still have to go back to the OEM, the original equipment manufacturer, to tell him that and they will charge you money for it. And so anytime, that is how the nations create dependency by through these things, that they will give you certain amount of equipment, but any upgrade, any kind of changes that you want, any kind of things you want to integrate, because like we discussed earlier, today it is network-centric warfare, it is multi-domain warfare. In a network, if I am not talking to you and you are not talking to me, then that network is of no use. You cannot fight as a network. You're still platform-centric rather than network-centric. So to become network-centric, truly multi-domain, we first have to have networks. And it must be able to talk to each other. That means it should be able to talk to AWACS, it must be able to talk to ground radars, it must be able to talk to between the aircraft. Let us say there's a Rafale which is flying and a Su-30 which is flying. Can they talk to each other? So that is ultimately, this is where we have to reach. And I think slowly we are going to reach there. It is just that we need to scale up our entire process of R&D and have a much tighter timelines to ensure that we are able to design, develop and operationalize equipment at a much faster rate than what we are doing today.
You were saying that for the each and every integrations, they will be charging separately. So on a lighter note, so is it like the product will be sold at X price, but the integrations will exceed the more than the product price itself when it comes to the aircrafts?
No, that may not. See, what happens is, one is the procurement cost, the other is the life cycle cost. So when you procure an aircraft, it costs you X amount. But the life cycle of that aircraft will cost you X plus plus. Now, when you want to integrate something, the original equipment manufacturer has to come and do that necessary modifications or necessary software changes, or it has to do lab testing, certification and all other processes which are there. So in that process, they will charge you extra money. That money will be something, but it will not be X plus plus. It will be way less than X, but then it is charging you. So it depends on how many aircraft you want modified, what is the kind of number of modifications you are doing, how many times you are modifying the aircraft.
Okay.
Because every time you want, let us say, today we are integrating a weapon, let us say Rudram, air to surface weapon. And tomorrow we want to integrate Astra 2, Mark 2. These are two different things. So until unless everything combines into a single project, then you can do different cost negotiations. But otherwise, this is the way everybody will create dependence on themselves. When they sell the platform, they will sell it and let us be very, very clear. Nobody sells you the top of the line operational things for themselves. They will always keep the highest end for themselves.
Coming back to our generation combat aircraft discussions today. So which capability would receive your highest priority? Stealth, sensors, networking or electronic warfare?
See, Vinay, it is not either or. Finally, there is a capability that you are demanding from a platform. And any additional characteristics only add to the platform, to the capability. So it is the mission effectiveness that will increase with every capability which is added on. So let us say if the basic platform remains a 5th generation, it is better than a 4.5 generation platform. So that is, you are ahead in that. Then when you come to sensor fusion, how much sensor fusion is done? It adds to the capability of the platform. Thereafter, electronic warfare. Now, electronic warfare, if the capability of electronic warfare between a F-35 and a Rafale is same, then both performance of electronic warfare are the same. But the difference will be that the stealth platform will not be detected at the range at which a Rafale is getting detected. So the stealth would go even closer. Whereas he is detecting a threat much earlier. But he is not being detected. So he is going even closer. So he is able to generate more data than what a Rafale could. So that when we break it down into separate capabilities, separate characteristics, they will offer us a value addition to each. But now when you do this on two separate platforms, then you can see then you can do the comparison. Now which platform will work better? So to say that whether sensor fusion or a radar or a RWR or electronic warfare, what it will do, they are all separate capabilities which are being integrated on a single platform. So the quality of sensor fusion, the quality of integration, everything will depend. But the fact remains that two platforms, one if it is a 4.5 generation and the other if it's truly 5th generation fighter, the 5th generation fighter, if everything is same, will be much better than the 4.5 generation.
Sir, so while stealth may improve survivability, air forces around the world continue investing in heavily advanced 4th generations. So what is the reason behind that?
Yeah, so if you see that if you see the wars now, what has happened is as the time has gone by, the defensive capabilities, lot of nations have started investing heavily into defensive capabilities. That is integrated air defense systems, and so it's multi-layered air defenses which threaten the aircraft more. So how could you bridge this? You bridge this by bringing in stealth. That is survivability. That categorizes you to be a little better than your enemy. Then when in the 4.5 generation aircraft, let us say there are two aircraft which have same range radars, which have same capability in terms of the thrust of the aircraft, the speed of the aircraft, and same range of beyond visual range weapon. So both will fire at their maximum ranges. And now, what is the difference between the two? The difference would be electronic warfare, if there is an electronic warfare difference. So this, as the range of beyond visual range air-to-air missiles continue to increase, this bubble was created that you cannot breach this. If you breach it, you're going to your survivability is at stake. So what is it that brought in? We brought in, similarly, the stealth came in. That means a stealth or a 5th generation platform would not get detected at the same distance as a 4.5 generation aircraft, and so it could go closer and fire a missile and still get a shot over the adversary. The same thing happened when you started going in the offensive mode, that is, offense against the adversary, offensive missions into his airspace. Now, when you go into that airspace, you are going to be faced with air defense systems. Now we compare 4.5 generation aircraft and a 5th generation aircraft. A 5th generation aircraft would be detected much later. And so with its long range weapons, it can create a solution without it becoming vulnerable to the air defense systems. This is exactly what happened during Iran-Israel war. That they were able to dismantle Iranian air defenses, all their long range air defenses, in the first, second, third wave of offensive missions. Now, once you do that, you now know that you're relatively safer. That means the threat to your other aircraft has diminished. Once that happens, you need now what you need is mass. The difference between a 4.5 generation aircraft and a 5th generation aircraft is a 5th generation aircraft can penetrate because of its shape, size, for its low observability, for which it has to sacrifice something. That means it cannot carry weapons externally. So it carries weapons internally. That means it has to sacrifice weapon load. Now, when it has to sacrifice weapon load, it cannot deliver the number of weapons or the weight of attack on the adversary. But now you compare a F-35, which carries about 4 to 6 missiles, or 2 to 4 bombs, with a F-15 which carries 11 tons of weapons, or a Rafale which carries 9.5 tons of weapon load. Now when this happens, in the first wave when you are doing, and the second part is the stealth aircraft are expensive. They are much more expensive, they are more expensive to maintain, they are more expensive to operate. And so you cannot have your entire air force made up of the 5th generation platforms. Because today the enemy is saturating you with his air defense, and you want to saturate or you want to create that mass of attack on the adversary to ensure that the effects are commensurate to the time. So when you do that, you have to have a combination of both these. So first, the stealth would go penetrate, create control of or seize control of air. That means it will diminish the enemy's capability to attack you. And now you go in with your mass and then deliver that weapon load across or in those corridors or at the point and place and time of your choosing. So you are creating a situation or an environment which is favorable to you to follow on with a 4.5 generation aircraft. So to say that only 5th generation platforms are required, no. We saw it during US-Israel-Iran war. We saw that once they achieved a certain degree of control of air, they sent their
F-15s.
F-15s, F-16s, F-18s. Everybody went in. So they were with the degraded air defense, the Iranians could not actually threaten them. What was lost is a different question altogether. There is a different topic of discussion altogether. How a F-15 was lost and how a F-35 was targeted is a different point of discussion. But conceptually, when we see, it is the mass which is important against a anti-access area denial strategy, which is being propagated, even by our adversary China. And so when you need mass, you cannot create mass by just 5th generation platforms. You need, and that is how you saw that once they achieved a certain degree of control of air, the B-52s, which is a huge aircraft, which carries 34 tons of weapons, a B-1 which carries 31, 34 tons of weapons. So these aircraft went and bombed without even a single aircraft being hit. But you imagine if they had started with that, number of aircraft would have been much more. So it is a combination which is very important, and I think India understands it better than anybody else, that there is a cost to acquisition, to development, and the mass that is required. And so no air force is made up of 100% 5th generation or 6th generation platforms. It will have a very balance of the most advanced, the contemporary, and a certain amount of legacy which are upgraded.
The 4.5 generation
I think for the next 15 to 20 years, we should be self-assured that we need 4.5 plus generation aircraft.
Yeah.
Even while in 2035, 2040 timeline, we will see operationalization of 6th generation. Yet, I think we will see at the same time 4.5 plus generation aircraft remaining with sensor fusion, with with upgraded electronic warfare, better radars, better long-range weapons. All these we will continue to see.
Sir, with the 4.5 generation aircrafts in the Indian Air Force disposal, now a MiG-21 has been retired, and we've been having a less number of aircraft squadrons left with Indian Air Force. So what would be your take on this?
I personally feel that whatever decisions that have been taken have been with a purpose. We need to beef up our fighter squadrons. Just LCA Mark 1A will not do, primarily because its weapon load is very, very low, just about 3.5 tons. And if we are going to integrate electronic warfare through an added pod or an IRST with an added pod, then your weapon carrying capability reduces further. And so what effect will it create when we talk about mass, when we talk about weight of attack? So it is still not a 4.5 plus generation aircraft. So LCA Mark 1A is primarily a 4.5 generation aircraft. So its survivability in a very, very contested air environment, its survivability in a very dense air defense environment will be questionable. And so we will need a 4.5 plus generation aircraft. So it is important that while we continue with LCA Mark 1A in certain roles, it will yield its effectiveness. But when we talk about mass and saturation, we will have to look at an early entry of LCA Mark II, along with Rafale, and upgrade Su-30. Su-30 in its present form will become vulnerable, and survivability will be questionable as we go along. It needs its radar upgrade, it needs its electronic warfare suite upgrade, it needs upgrades in various systems. And so for it to become a 4.5 plus generation, upgrade is very, very important. And so acquisition of Rafale needs to be faster. AMCA needs to be faster, much faster. If South Korea can develop a KF-21 in 44 months, when they had planned to develop it in 48 months, why can't India do it? Is the question that I ask myself. And that is a question I think we need to ask our design developers and R&D organizations and everybody who's involved in manufacturing. That why so much of time is being taken to just shortlist, to do identification of who will build it, how will it be done, and then testing. And so a phased approach, what has been adopted both by Turkey as well as South Korea, I think is a good approach to incremental increase in capability. And you cannot, in our own ecosystem, we cannot jump from 4th generation to 6th generation till we don't go through the learning process of 5th generation. And so how do we shorten this process? We have to shorten this process by shortening the research and developmental cycles. For that, whether it is investment, whether it is early approval of projects, whether it is ensuring that the right people are there, whether it is oversight of the project, whatever is required to be done must be done. Because we cannot remain behind the world standard for any longer. And so when we talk about Indian Air Force, we need a force structure today where we first beef up the capabilities in numbers and in capability very, very quickly. And then continue to first bridge this gap to a certain extent and then build up on the strength and capability. It cannot be a one-track approach. It has to be a multi-pronged approach. Then just one-track approach that, okay, we will do this and then we will do this and then we will do this. So LCA Mark II has to come very, very quickly. And so how are we delayed on engines is a question.
So there is sir, we have like a production line of the HAL as well. There have been questions on the 12 aircrafts per year and the engine has been delayed. But these delays have been on the papers and the news for a long time, where it has been more than 4 to 5 years itself. So who could be answering the delay and why it is happening? That is also a question from us as well. And when it comes to the R&D part, when we are investing the right set of might be technology or the manufacturing itself, so we've been not able to do that in a prescribed way. But when the AMCA is coming now, it is set, and how we could streamline the development and the manufacturing in the much faster pace. What would be your suggestions and take on that?
I think firstly, there are multiple organizations in India which are involved in every project that we have. If we see LCA, there is one DRDO which is developing, there is HL which is manufacturing, and there is Air Force which is the user. Similarly, when we go to AMCA, it is DRDO which is developing. A private partner would be chosen between I think Tata's, L&T's, Bharat Forge, and that consortiums that they have made. One of them will be chosen to manufacture, and Air Force would be the user. So once again, you know that there are multiple verticals which are working on a same project. And when these multiple verticals are there, are they aligned with each other? Is there an oversight which understands where the complexities are? Is there an oversight which is able to forecast what are the risks that are likely and how are we going to surmount those risks? What is the accountability of each organization? How are we ensuring that the timelines are being adhered to? What is the timeline plan? And how is it being done? And how are delays being forecast or not being forecast? And so I think we should learn from what happened in LCA Mark 1A or LCA Mark 1, or what even happened during HF-24 Marut, or any aircraft that we have developed so far, and then put it to test against the world standards today, and then see where are we not doing it right, and have an oversight which has the expertise and the professional competence to have the oversight, not a theoretical oversight, but a practical oversight. And so, if we don't do this, we will continue. It is like I keep asking this question. You know, Sindoor is more than 1 year old. What have we brought new after Sindoor as a capability for the Indian Air Force? So that is the question I ask. And that is the proof of the pudding. We have to ask this question, that how are we going to do it? What we know we want to make an AMCA, but how will it be done? Who is going to play what role? That also is theoretical. But practically, why are we facing these delays? We should learn lessons and ensure that we don't make the same mistake again and again and again, which we have got used to, unfortunately. And so, LCA Mark II should be our first, yardstick, whether we are able to achieve it or not. And that will show to the whole world whether we are doing it right or we are not doing it right. We have to put more money into our system. Research and development is prone to failures. We must have the stomach to accept failures first. We must have incentives to spur research and development. Those incentives have to come from the government. It cannot come from the private sector initially. But at certain point in time, the private sector will have to stand up and take ownership of research and development. The funding for research and development must increase. The entire infrastructure for research and development, whether it is facilities, whether it is certification, whether it is testing, whether it is simulation. Today we send our Kaveri engine for airborne trials to Russia. So we are hostage to Russia to that trial. Now if that aircraft is not free, the trial will be delayed. So my point is, why we have IL-76? Why can't we modify one of the IL-76 and make it a airborne test aircraft? Why are we not making the difference? So this is where we will have to put money. The infrastructure will have to be built up if we want to move in that direction. Otherwise, we will remain dependent on various other nations, and that dependence is going to create time delays. And so it's an ecosystem. Research and development is not just one thing. It is made up of many, many things. And everybody is a stakeholder. And each stakeholder must be held accountable. Till we don't do it, we will continue to make the same mistakes.
Thank you for sharing your time, your experience, and your insights. Thank you so much for coming here.
Thank you, Vinay. Thank you. It was great to be on the show. It was nice to interact. I think as a nation, we owe it to our nation as armed forces, or as a nation to our armed forces, that they are absolutely capable. They have contemporary and most technologically advanced systems for any contingency. We know we live in very, very difficult times. There is I was reading somewhere, there are more than 100 conflicts which are ongoing in the world. And so in a very complex, dynamic, volatile world, and especially in a very complex neighborhood that we face, with both our adversaries investing so much in their air power, I think it is time that we invest in our air power much more, and we make things happen much faster. Thank you.